Hello, this is day 3 of the unit circle. Now that we've put the unit circle together and we can use it, we could also use it not just for one revolution, but for more. So if we're looking at the first one, 17 pi over 6, you can convert it to degrees, or you can keep it in radians. Because of the denominator of 6, I know it's a reference angle of 30. But I need to figure out what quadrant it ends and it terminates in. So if I keep it in radians, just so we can practice, I know 2 pi, if I'm converting it to sixths, that would be 12 pi, right? 12 over 6 is 2. So that's one full rotation, so 17 pi over 6 minus 12 pi over 6 is 5 pi over 6. So I'd say I have one full rotation, and that rotation doesn't really matter to find the value. What matters is at the end. So I have until 5, 6. So it's going to fall in the second quadrant. So you do exactly the same thing as if it was just one revolution, but you just have to, if it's less than one revolution, but just more, you just do the full rotation and then see where it ends. Once you figure out where it falls in what quadrant, then you do the regular thing. Find the reference angle. We know the hypotenuse is 1. Find the lengths. Cosine is adjacent over hypotenuse. So my final answer is negative root 3 over 2. All right. For this one, because I'm in twos, that's a lot of halves. Let's try to do it using the degrees. I'm going to change this to degrees, and it's 1710. So how many full revolutions is that? I think it's going to be 4. So what is left? 270. So you went 4 complete turns around, and now we're going this way. But again, it doesn't matter about the 4. But I care about once you get to here, back to here, on the 4th time, we're going 270, which is right there. Okay. So right there. Ooh, can I draw a triangle? No. So this is a special one. And our point is 0, -1. Now we can do this a couple different ways. We know that tangent is y over x. So cotangent would be x over y. Or you can look at your paper. That helps you. So because it's a special angle, it's going to be x over y, which is 0 over -1, which equals 0. Now on your piece of paper, they didn't have a negative 270, but that is the same as a positive 90. Same. Oh my gosh. Did I say -1? I meant positive 1. Sorry. But the answer is still the same. All right. So for trig functions, we can also do operations with them. Add them, subtract them, multiply them. So what you have to do is evaluate each one first. So you're going to find sine of 30. It's our first quadrant right here. That's 30. This is half. This is 1. So this is root 3 over 2. So I know it's opposite over adjacent. So this is going to be half. Tangent of 135, that's going to fall in the second quadrant here, right? 135. So this is 1 root 2 over 2, root 2 over 2. Because it's tangent, it's going to be opposite of adjacent, so they are the same number, so it's going to fall and equal to -1. And then we just simplify. So it's half minus common denominator, 2 over 2, so that's going to equal -1/2. Sometimes they won't come out that neatly, just so you know. You may get crazy fractions and roots for your answer. All right, cosecant of 45, first quadrant, root 2 over 2, root 2 over 2, 1. So cosecant is, what is cosecant? Sine over sine, sorry, it's reciprocal of sine or hypotenuse over opposite. So this is the one that I know. This is going to be the square root of 2. So it's this. It's reciprocal of that, which simplifies to there. Cosine of 60, first quadrant. So this is root 3 over 2, 1, this is half. Okay. So cosine of 60 is a half. So we're multiplying. This is multiplication, right? When there's nothing in between, this means times. So it's root 2 times 1/2, which equals root 2 over 2. All right. So this is 5 times this. This is 2 times that. And then we're going to subtract. So how much is 3 pi over 2? 3 pi over 2 is a special angle. It's here. This is 0, -1. And remember that sine is the y value. So that's 5 times -1 minus 2 times cosine of 3 pi over -3 pi. So 3 pi, 2 pi is 1 complete all the way around, and then a negative pi is here. So that point then is -1, 0, cosine to x value. So that's times -1. So this is -5 times +2, which equals -3. So for these, you just evaluate each one and then do the operations using the order of operations. So that never changes. All right. There is a pattern when you look at sine, cosine, tangent, cosecant, secant, cotangent around the unit circle. And it has a relationship about whether it is positive or negative in a particular quadrant. So let's look. So this is our unit circle now completed. We have the angles here in degrees and then in radians next to it, and then the points. So when we say sine positive or negative, we're talking sine, cosine, tangent, cosecant, secant, cotangent. This is for the first quadrant. This is the second quadrant, the third quadrant, and the fourth quadrant. So in the first quadrant, they're all positive, right? And there's none that are negative. Now in the second quadrant, remember sine is the y value. And we learned this when we found out about our points and using them for the special one. So we can see that the y values are positive, which are sine. So sine is positive. And its reciprocal, cosecant, is also positive. That means all the other 4 are negative. So that is cosine, secant, tangent, cotangent. And here, both the x and y are negative. So when you do, and those represent the legs. So a negative is positive, and that's the tangent. When it has the opposite over the adjacent, or they're cotangent when it has the adjacent over opposite. And therefore the other 4, and I will always put the pair together with its reciprocal because that's important. So the last one, if we're looking here, the y values or sign are negative. The x value, which represents cosine, is positive. So this is cosine and secant. And then the other 4 are negative. Oops, wrong one. And when you do your problems, you can look and say, is that true? And some of you may have picked up with that pattern already. So make sure you write this down with your unit circle as well. This will help you. Also double checking to make sure, again, that you don't drop that negative at your final answer. So in your final answer, if I'm in the 4th quadrant and it's sine, even if I may not know what the number is, I know this, the sign of the sine is going to be negative. Right. So here's a summary. This is what many people use to help them remember about the signs, because not everyone's carrying a unit circle around with them. Draw the quadrants, and they say this: all students take calculus. I never thought of one that I can remember. This is the one that I learned in high school, and this has stuck with me all these years. So all students take calculus. Now, this is only for the big 3. When I say the big 3, I mean sine, cosine, and tangent. So when it says all, that means all of them, right? That we had said earlier, sine, cosine, tangent, cosecant, secant, cotangent, they're all positive. Here, sine is positive. So this tells you positive. See this? It is a coordinate plane, but it's also a big plus. But it's also its reciprocal, cosecant. What's positive here? Tangent. And its reciprocal, cotangent. What's positive here? Cosine and secant. So all students take calculus. You'll see this on pieces of paper. I tell students to draw it in the corner. It'll help you. There is one thing I don't think I mentioned. I don't know if you noticed that for the first quadrant, all 6 are here. But for the other quadrants, you only had 2 positive and 4 negative. 2 positive, 4 negative, 2 positive, 4 negative. So once you know positive ones, then everything else is negative. And this is why they use this. All students take calculus. So let's apply it. So name the quadrant in which the angle, pi lies? Ooh, that shouldn't be a pi, sorry. It should have been the angle theta lies. I typed in the wrong thing. Okay. So the angle here lies. Now there's no number, but what does it tell us? And this is what it's important that with all students take calculus. You can figure out whether it's positive or negative in the quadrant if you know the signs of 2 the trig ratios. So here, if it's less than 0, that means it's negative. It's greater than 0, then it's positive. So it's saying like this. Okay, here I'm going to be in my corner. All students take calculus. Wrote that. So what quadrant that sign's negative in, but cosine is positive? Okay, so I usually do the positive one. So cosine is positive here and here. And then it says sine is negative. Well, everything's positive here, but sine is positive. Sorry, I said that wrong. Okay, cosine is positive in the 1st and 4th quadrant, right? So it has to be one of them. But then you look at the other one. Well, sine is negative here and here. So between these two, so here, it's either the 1st or 4th quadrant, but it can't be the 1st quadrant because everything's positive there. So the answer is the 4th quadrant. Okay, let's show the next one. So I'll take, both of them are positive. Okay, that one's not hard. Where are they both positive? Tangent and cosecant, there's only one place. So it's for tangent would be the first and third. In cosecant, it goes with sine. That's only the first quadrant. Okay. Now, cosecant, this is where you have to be careful. It's not C, this is actually sine. Remember, it goes with its big brother, the top three, the big three. So where sine is positive and cosecant, which goes with cosine, is negative. All right. So sine is positive in the first quadrant and the second quadrant. So where's cosine? Well, cosine is positive in the first, but where's the negative? Here. So it can't be that one. So it's that one. All right. Now that we've done the unit circle and the hypotenuse is 1, that doesn't mean all circles and all triangles, the hypotenuse will be 1. So let's look at this one. So here it tells me, very similar to what we did before, sine is 5/13, and it's positive. And cosine is negative 12/13, and it's negative. So what quadrant is that in? Okay, all students take calculus. Okay. So sine is positive in the first and the second, and cosine's going to be negative, so it can't be the first because everything's positive. If it was in the first, cosine would be positive too, but it's not. So my quadrants in the second quadrant, my sine is this, right? Opposite over hypotenuse. Here's theta. So my opposite is here, 13 is here. So my negative 12 for my cosine would be there. So we want to make sure we have the right triangle so we can find the rest. So tangent is 5/-12. Cosecant is 13/5. Secant is negative 13/12. And cotangent is negative 12/5. All right. So again, hypotenuse is not 1, can't be 1. So it's not the unit circle where the hypotenuse is 1, but if you see this, it still holds true for all triangles on the coordinate plane when you're doing the trig functions. We're in the second quadrant, so we could see that sine and its reciprocal, cosecant, is positive. Everything else is negative. All right, so let's try this one. Okay, so it says cotangent is 2/5. Okay, but that doesn't tell me enough information just in this one part, because cotangent, which goes with tangent, one of the big three, all students take calculus. It can be positive in the first quadrant and the third quadrant. So I need more information. And then this will tell you the more information. It says theta is between, less than, pi, which is here, and 3π/2. It's going to be in the third quadrant. So I'm going to draw that. And why is that important that you draw it right? Well, cotangent is adjacent over opposite. So the adjacent is 2, the opposite is 5. Okay, if you do that, is that possible? Can the hypotenuse be what? No, it can't be. This leg can't be bigger than that, so it's not a unit circle. So I have to find the hypotenuse. Also, because I know I'm in the third quadrant, these are actually both negative. And that's an important thing to do. If not, the rest of your 4 will be wrong. So I'm going to find the hypotenuse using the Pythagorean theorem. So I'm going to do -2 squared plus -5 squared equals c squared. All right, this is 4 plus 25, so that's going to be 29, and you're going to take the square root of that. So square root of 29. Okay, now we need sine, cosine, tangent, cosecant, and secant. Okay, so sine is -5 over root 29. So you can see if it's negative, if I did not put the negative here earlier, it's going to make sine wrong. So simplifying it is -5 root 29 over 29. Cosine, adjacent over the hypotenuse. Rationalize the denominator. Tangent. Negative and negative is positive. So again, you're like, but Miss Mendoza, I'm still confused. Why? They were both positive. But why did I put negative? Because we know it's in the third quadrant. And in here, right, my point is negative, negative. So I have to put the negatives. And when you put 5 over 2, a negative and negative is positive. So that's what happened. They did have negative signs, but they simplified or canceled out. Okay, this is going to be square root 29 over 5. And the square root of 29 over 2, negative. Okay, so remember I should have 4 negatives. 1, 2, 3, 4, and 2 positives. 1 here and 1 there. Right, and these are practice on your own. Take your time. If you're stuck and confused, go back to the video or review the last problem, see where these problems match what part of the practice problems earlier or the examples. All right. Thank you for watching. Don't forget to answer the EQ. Bye.